Alright, so this is how to do number 5 on page 245, chapter 10, section, what, C? Yeah, C. Section C. So we looked at this problem originally a while ago, but we are coming back to it again. So I wrote down some of the important information that's given to us. One revolution takes 100 seconds to complete, the radius of the wheel is 10 meters, and the bottom of the wheel is 2 meters above the ground. So in order to solve A, I realized that the full height of the sine graph is going to be the radius times 2. So the radius times 2 was 20, and then I divided that by 2, which equals 10. Now, I went about that in a roundabout way. You really just know the amplitude, A, by looking at the radius. So, yeah, but, you can do it in my weird roundabout way if you want to. So to find B, which is period, all we had to do was look at how long our revolution is, which is 100 seconds, and then put that in as our B value in the denominator of the equation 2 pi over B. And we know that the sine curve is 100 seconds because it's the same as 1 revolution. Basically, this lovely little circle that we have here is the same thing as a sine wave, just in the form of a circle. Like I drew it out here because my brain wanted to visualize it really badly. So this is like, if you just took this and flipped it over, you got a little circle. So this thing is the same thing as 1 revolution on a circle. So all we did was plugged 100 into the equation and got pi over 50. And I checked that in the book, so it's right. So to find C, which is the horizontal translation, we just needed to figure out where the first middle point is, and then after the middle point, it needs to go up. So I did this by looking at the circle. So we have the minimum here, so we can't start our sine wave here because then our sine wave would just go like this. And that's not what a sine wave looks like. A sine wave looks like this. I hope that makes sense. Makes sense in my brain. So here, when we're a quarter way through the wheel, the sine wave goes like this. So because it goes up like this, and then it goes down, as you can see in the rest of the wheel, and then it goes up again a little bit. So it goes up, down, and then up a little bit again. So we're just looking at this point right here as where our sine wave starts. And in order to find that, we took the time of 1 revolution and divided it by 4 and got 25 seconds. So I'm actually going to mark that right there because I like that and I like having it drawn out, even though it doesn't say we need to have it drawn out. So that's 25 seconds. So D, ignore the scribbles, I messed it up in the first place. So for D, we need to find the vertical translation, and that was actually very easy. As the problem says, the bottom of the wheel is 2 meters above the ground. So all we had to do was add 2, which is the height of the wheel at its minimum above the ground, and then add the radius, because the radius is 1/2 of the total height of the thing, also known as the amplitude. So we just had to add 2 and 10, and we got 12. So I'm going to write our thingy out here. Can you see this at all? Maybe. I'm looking on 2 different things. I'm looking on my paper, and I'm also looking at my phone. So A equals 10. 10 sine of B, which we found to be pi over 50. And x minus 25 seconds. And then we add 12, which is our D value. And this is our answer. I hope that made sense.